中文讲的不好，我就用英文来讲了啊。So my name is Bill Zhang. I'm the Cloudera responsible for the Open Data Lakehouse implementation based on Apache Iceberg. So I'm going to talk about the Open Data Lakehouse. I guess why Open Data Lakehouse and why we're based on the Open Data, the Apache Iceberg as a table format, and also to share some of the real world use case. So let's talk about what is Open Data Lakehouse, right? So we talk about Lakehouse, I think, in a lot of use cases before, but where's the Lakehouse coming from is actually is a combination of both worlds, basically coming from a data warehouse and a data lake. And so each of them actually have both pros and cons. So for data warehouse, pros is that you can use open data warehouse for very structured data and always give you very predictable performance, right? The predictable performance is really one of the key tenets for the data warehouse. But downside for the data warehouse is that very limited storage. And sometimes you have to build a very complicated pipeline as well. Now, coming to data lake, Cloudera is one of the pioneer for a data lake. Now, the advantage of a data lake is you can actually ingest lots of data, right? Petabyte data into the data lake. But downside of a data lake is that when you try to extract actionable insights, sometimes you have to build a very complicated pipeline to generate those actionable insights. And a lot of times you cannot even use SQL as a language, right? So would that be great that if you can use SQL as a language and are able to query petabyte-sized data and also give a very predictable performance? Hence the terminology or architecture data lakehouse coming from. And so what kind of, I guess, challenges that Open Data Lakehouse actually resolve? One is data staleness, right? So many of us actually implement that you have to, let's say, building a pipeline, copy the data from data warehouse to data lake. And then once you copy the data, it means that there's a latency between data warehouse and the data lake, right? So Lakehouse, since a combination of both worlds, meaning that you don't have to copy data from data warehouse to data lake. So there's no latency between data warehouse and data lake. So data staleness problem is gone. And data quality, and the data, I should say data reliability. From data reliability perspective, again, is also because of the difference between warehouse and the data lake. And with Lakehouse, just one copy, right? So there's no reliability issue that you can predict from some of the pipeline you are building. And also, Lakehouse has very strong support for advanced machine learning, ML, the AI, ML, supports very advanced analytics, and because a lot of compute engines actually support Iceberg table format nowadays, so very strong support for the advanced analytics as well. And also TCO. TCO is also coming from, you don't have to copy the data, first of all, saving the storage, and also some of the operational costs, right? So you don't have to do a lot of operational issues based from the Iceberg. So saving from reduce the storage cost as well as some of the operational costs. So those are the four things that I would say how data warehouse, the data lake is solving some of the challenges that we're seeing from data warehouse and data lake perspective. So Cloudera used the Iceberg table format as the foundation for Lakehouse. So I'm not going to go through detail in terms of what is a Iceberg table format, but just a couple of things that I want to highlight here is the difference between. So previously I was also Hive product manager, and my engineering team's right there. The major difference between Hive table and Iceberg table is the metadata, right? How metadata is being managed so differently between Iceberg and Hive table. I would say this is also I think when I was talking to Ryan Blue, one of the things that Ryan Blue is also coming was a Cloudera as well. So some of the deficiency that how Iceberg solved Hive table metadata issue. Number one is that the metadata itself is actually not stored in any meta store, right? So we all know that meta store is in the database. Every time you try to retrieve some of the stats, you have to go to the database to retrieve the stats. There's a bottleneck there. But Iceberg table, all those metadata is actually in the directory is the file itself, so there's no bottleneck. And able to solve some of the performance issue, scalability issue that you're facing from Hive table, especially when you have a lots of partition and the data, and also the file size, database size getting very, very big. So I would say that the major thing is really coming from how metadata is being managed between Hive table and the Iceberg table. And my colleague, I think tomorrow is going to talk about some of the differences between Hive and then the Iceberg. So I'll go to my colleague's session as well. But this is, I want to say, Iceberg is able to solve a lot of the performance issue, scalability issue, and also data management issue, right? So one of the issues we're seeing from Hive table side is when you try to do, let's say, partition evolution, right? Partition evolution is pretty important, especially in a lot of machine learning cases. But with Hive table, every time you do the partition evolution, guess what? You have to regenerate your entire Hive table. When you have a petabyte-sized Hive table, it's going to take a very long time. But Iceberg table, no table regeneration. So this is one of the major advantages that we're seeing why a lot of our customers choose Iceberg over Hive table today. So also want to highlight some of the key Lakehouse capabilities are really based on the Apache Iceberg. Number one is really the asset transaction, asset compliant transaction. So as you all know that asset capability is out of box, meaning that by default, Iceberg table is asset compliant. Hive external table, Hive versus Hive asset, right? So Hive external table, there's no asset compatibility. And later on, we introduced the Hive asset, but have some problem in terms of performance and the scalability. But Iceberg table, because how metadata is managed so differently from Hive asset table, so that asset has become a really default from the transactionality perspective. This is actually number one reason we're seeing a lot of customers using Iceberg table over Hive table today is because asset compliant transaction, right? Number two is really the time travel. So Hive table, you guys used the Hive table before. There's no time travel capability, meaning that you cannot go back to snapshots, right? Hive asset actually have a notion of a snapshot, but never had the capability that you can go back in point in time. So, but the time travel now is a native capability within Iceberg table because all those snapshot capability that introduced in as part of the Iceberg. So this is something that's very important. And also table rollback. Table rollback is another key feature we're seeing a lot of customers really taking advantage of. In many of the data warehouse system, you have a table rollback, but you don't see that in the Hive table, right? So now, because of a snapshot capability within Iceberg, you can always go back point in time. You can reset the pointers, reset the snapshot, going back point in time. So this is how table rollback works. It's a very important concept. We only see that data warehouse data warehouse have this capability, but now with any Hive table. Now Iceberg table, out of box. Number three is really the in-place partition evolution. As I mentioned that we're seeing a lot of customers taking advantage of this capability because especially when you have a different ingestion pattern. Sometimes ingestion pattern changes. You want to partition your data sets maybe by days, by hours, so differently based on how the partition ingestion pattern changes. Now, with partition evolution, especially the in-place partition evolution, you don't have to regenerate your entire table. It's very important for a lot of customers that you don't have to taking hours and hours getting the table regenerated because you change your partition schema. Table maintenance and is another important aspect. Well, I would say compare this capability. Hive previously have something called a Hive Asset. Hive Asset actually has building major and a minor compaction automatically. So, but that automation done through the Hive Meta Store. So there's complications there. And I would say from Iceberg side, the table maintenance is decoupled from Hive Meta Store. So there's no event listener. You don't have to actually rely on the Hive Meta Store in order to do a lot of compaction. So Spark procedure, you can do compaction. And Hive table today, I'm sorry, Hive engine and the Impala engine, including Flink, now they also have some of the table maintenance capability. And then tomorrow, if you go to our session, there's also automated table maintenance also building from Cloudera as well. But table maintenance, I would say, is a very important aspect of Apache Iceberg table as well. Uh, the next one is really the multi-engine interoperability. It's very, very important. I don't think there's any compute engine kind of one size fits all, meaning that each compute engine has its own advantage. And we're seeing a lot of customers really taking advantage of a multi-engine compatibility. What does that mean, right? So you can use a Flink CDC to do a lot of, let's say, streaming ingestions, right? And then on the other end, you want to use Doors, right? You're using Doors to do some of the BI workloads. So that is a typical example of a multi-engine compatibility. So using one engine to do ingestion, another engine try to read the table in the same time. Very important aspect, and seeing a lot of customers really taking advantage of a multi-engine interoperability. And I would say in-place table migration. So we have a lot of customers are using Hive table today, and now one of the key things that what they're looking for is when they convert Hive table into Iceberg table, they don't want to rewrite table, right? All you need to do is changing the metadata of the Hive table. So essentially, you rewrite your metadata Hive table into the Iceberg table, voila, you have your Iceberg table. So this is something that built into Spark procedure has a Hive engine, Impala engine. They all have those type of in-place table migration, and then making the Iceberg adoption very easy from that perspective. Now, I don't see many of the conversation today happening with the branching and tagging. But branching tagging is actually very, very important, very interesting concept as well. We're seeing many banking customers actually taking advantage of this branching tagging, especially when they want to, let's say, reserve a copy of the data for end of a quarter, end of year, right? So because when you do auditing, you want to keep of the data just for the auditing reason. So when you create a branch, you create a branch of your data for end of quarter, end of year, reserved for the auditing purpose is very important. So branching tagging, very important. And you don't copy the data, right? When you create another branch, you don't have to copy the data because all you need to do is actually, that's a metadata manipulation. That's important from that perspective. Now, streaming and the batch ingestion, as I mentioned, this is also because of multi-engine interoperability. There's a lot of compute engines that you can do streaming ingestion, a lot of compute engine you can do batch ingestion on the same table format. So this is something that I would say satisfy many different use cases based on the use case requirements. So those are the key capabilities really enabled by Apache Iceberg and also leveraged by the Lakehouse implementation. Next, I want to say that how Cloudera actually implemented the Lakehouse. So this is, I would say, our architecture. If you can think about kind of layer the cake perspective, on the top are just all the different compute engines that we do support today. So you have streaming processing, that's a Flink compute engine. Of course, all the compute engines that we have is containerized in a Kubernetes operator format. And the data flow is the NiFi compute engine. And the data processing, that's a Spark compute engine. And then also you have the data warehouse, that's a Hive, Impala, Trino. And AI, that's our AI ML workloads. Now, I want to highlight the blue box, right? And thanks to Iceberg REST catalog, and now you can actually allowing the third-party compute engine going through the Iceberg REST catalog, querying the all the Iceberg table in our system without actually copy the data. Essentially, it is doing zero copy, zero ETL data sharing, all thanks to the Apache Iceberg REST catalog. And so some of the popular compute engines out there, Databricks Spark Engine, and also Snowflake BI Query Engine, even Salesforce Data Cloud can all query our, I would say, Cloudera Lakehouse Iceberg table format, all thanks to the Apache Iceberg REST catalog. Now, another important aspect built into our architecture is the security and the governance, right? So for any banking, government, telecom, a lot of our customer in those verticals, what they're focusing on is really the security and the governance. What does that mean? By the way, all those security and governance is really based on the open source project, right? So this is a Ranger and Atlas. So for example, you want to do fine-grained access control. What is fine-grained access control? That is column level masking and the row level filtering, and all doable through our Ranger and the Atlas. And if you want to do auditing capability as well, it's all built in, right? So, and I know as part of the, I would say, Iceberg, that there's some recent proposal doing the Iceberg through the REST catalog for the fine-grained access control. So the idea is, I would say, is very similar, but I would say that the proposal is very elegant in a way that is not compute engine dependent, is solely on the table itself. So looking forward to the fine-grained access control through the REST catalog in the community coming up. Now, we also build in Lakehouse services because we're dealing with a lot of banking and banking customers. The number one ask from those banking customers, they want a disaster recovery solution out of box, meaning that they want to do replication, right? So we have Iceberg replication, and I don't think you can hear many of the enterprise actually supports the Iceberg replication. We're the only one in the market actually does that. The important thing about the Iceberg replication is that when you move, it's just not simply moving data files. The important thing is that you want to move metadata and the data files atomically at the same time, because if you just move the data without the metadata, data file is by itself doesn't make much sense without the metadata, right? So you have to move, you have to copy the data and the metadata atomically. That's really the key thing. And then we've been achieving this for many years for this Lakehouse Iceberg replication. And the second thing is, I would say, the optimization. So you guys heard about Amaro. So we have the Lakehouse optimizer built into our platform as well. First of all, it does the table maintenance automatically. But we actually move beyond the table, just a simple table maintenance, right? Table maintenance about compaction of your small files. You do the snapshot expiration, right? So all those are really the simple maintenance. But what if, let's say, you can, based on your query pattern, can I generate your materialized view automatically? So can I actually regenerate some of the data files based on your query pattern? So you have to build in those intelligence, and based on the query patterns you have, generate a materialized view, moving the data files automatically. So those are all part of the Lakehouse optimizer. That's something that we are working on right now. But the first thing is really having the automated table maintenance already be there already. So those type of things that are available as part of our Lakehouse architecture perspective. And also important thing is that with Iceberg, you can actually deploy your Lakehouse anywhere, meaning that in the public cloud, of course, supports AWS, Azure, Google, and also on-prem, right? Your own data center. We have, so in this conference, we're also going to talk about Ozone. Ozone is an on-prem object store. I think originally it was coming from Tencent, and of course you can deploy the Iceberg on top of HDFS as well. So this is essentially you can deploy the Lakehouse anywhere, whether it's in public cloud or your own data center. So this is the architecture, how Cloudera implemented Lakehouse. And then next couple of slides, I want to talk about some of the real world use cases, all coming from our customer base. The number, of course, I removed the customer name. The number one is what we call the customer 360. Customer 360 is this is from a commercial banking customer in Asian Pacific region. So what they're looking for, their use case is what they call MBA and MBO, right? So next best offer, next best action. So that is really the use case. So what they want to do is actually providing the MBA or MBO based on the transaction pattern. That's a banking transaction pattern. And also, interestingly, the social media sentiment, right? So in this case, they are using some of the raw data coming from TikTok. So imagine you're this banking customer, and so you have a banking history, and that they're using the Spark engine to do the batch ingestion of your banking history, whether you, what kind of banking history, you do the deposit, you do the withdrawal, all those banking histories are actually, if you are taking any loans from this commercial bank, all those banking history is actually batch ingested into the Lakehouse. And also, they're using NiFi engine, whether it's using real time or batch, to capture their competitors' offering, right? So because they want to understand what the competitor offering, so they can offer better deals for their customers. So they're using NiFi to actually ingest those things. And also, for each user, they also collect their social media. So that, in this case, is TikTok. So they're using TikTok ingest into Kafka, and the Kafka into NiFi. And of course, in the community right now, there's a Kafka and Iceberg connector. So that's the next evolution. But in this case, they're using Kafka ingest that into NiFi. And then, and so you have those banking history, you have competitors offering, you also have social media. So they're combining all those data using Spark engine to do a lot of processing and to figure out what is really the next specs, MBA and MBO. So that's really the use case, very interesting, and then the data just keep growing because the user population is very big. So this is, I would say, a very interesting use case, and once we introduce this use case, and we're seeing a lot of banking customers that we have mimicking this kind of use case, I would say patterns. This is customer 360. The next one is the near real-time analytics. So I would say this is a satellite provider. You guys heard about Starlink, right? Starlink is the Elon Musk company in US. So this is a very similar provider in Europe. And so what they want to do is providing near real-time analytics. So they are providing satellite services for a lot of European customers. And in this case, they have multiple external data sources, whether it's from database, whether it's from files, and then they are using Kafka to do the data ingestions. And then from a batch perspective, they're using Hive as a compute engine to do the data ingestions. And then once you have NiFi doing the streaming, Hive to do the batch, and then Spark engine does the processing. And they are combining the analytics on streaming and the batch data. And so this is how the processing was done. And then they're using Hive LLAP. I don't know how many of you heard about Hive LLAP. So Hive LLAP is the one that they're using to do the BI query on top of those Iceberg tables. So this is another use case. The interesting point here is really they're able to use different compute engine on the same Iceberg table, but combining the streaming and then the batch data into the same Iceberg table. So that is the interesting use case. So that's a near real-time analytics based on the Iceberg table with different compute engines. So this is kind of, I would say, some of the two use cases I want to share with you. So this is I think this is it, and thank you very much. Time for Q&A.